China's audacious stride towards lunar exploration marks a new era, as the Long March-10 rocket successfully clears crucial propulsion tests, solidifying its role in the nation's moon-bound ambitions. This towering behemoth of technology, designed to transport astronauts by 2030, demonstrates significant advancements with a liftoff thrust of 2,678 tons and a payload capacity thrice that of its predecessors. As we delve into the capabilities and recent triumphs of the Long March-10, we uncover the intricate dance of engineering and aspiration that propels China closer to the lunar surface. Join us as we explore how this monumental leap could reshape space exploration. The Long March-10 rocket is a testament to China's significant advancements in aerospace technology. Standing approximately 90 meters tall with a liftoff mass of 210,000 kilograms, it is designed to transport heavy payloads, specifically up to 27,000 kilograms, into lunar transfer orbit. This rocket, developed by the China Aerospace Science and Technology Corporation (CASC, represents a pivotal component in China's ambitious goal to land astronauts on the moon by 2030. One of the key innovations of the Long March-10 is its first stage, which incorporates 3 5-meter diameter cores. This design allows for substantial thrust, achieved through 7 YF-100K engines per core, each producing around 130 tons of thrust. These engines burn kerosene and liquid oxygen, a combination that provides the necessary power for deep space missions while being more environmentally friendly compared to traditional rocket fuels. The development of the Long March-10 is part of a broader strategy to enhance China's capabilities in space exploration. This rocket builds on the legacy of the Long March series, which has seen continuous improvements in payload capacity and reliability. The Long March-5, for example, was previously China's most powerful rocket, but the Long March-10 surpasses it by a significant margin, particularly in its ability to transport larger payloads to the moon. This leap in capability is crucial for the planned lunar missions, which require transporting both crewed spacecraft and landing modules. Furthermore, the Long March-10 is not just about raw power. It incorporates several advanced technologies that enhance its efficiency and safety. The use of modular design allows for flexibility in mission planning, accommodating various payload configurations. The integration of advanced materials and manufacturing techniques also contributes to the rocket's overall performance, reducing weight while increasing structural integrity. The journey to achieving a successful manned mission to the moon is paved with rigorous testing and validation processes. The Long March-10 rocket has undergone extensive testing to ensure its readiness for the demanding requirements of space travel. Central to these tests are the YF-100K engines, which have demonstrated remarkable reliability and performance under various conditions. One of the critical milestones in the testing phase was the simultaneous ignition of 3 YF-100K engines. This test, conducted at the Academy of Aerospace Propulsion Technology in Chang'e Province, was a crucial step in verifying the engine's capability to operate smoothly and reliably. The engines were tested for their ability to start and shut down precisely, and to maintain stability throughout the firing duration. Additionally, the engines have been subjected to high-altitude simulation tests, which are designed to mimic the conditions they will face during actual space-based missions. These tests assess the engine's performance in a vacuum environment, ensuring that they can operate effectively outside the Earth's atmosphere. The successful completion of these tests has been a significant confidence booster for the engineers and scientists involved in the project. Beyond engine testing, the Long March-10 has also undergone structural integrity tests, including static load tests on its thrust transfer structure. This structure, which mounts 7 engines in parallel on the first stage, is critical for distributing the immense forces generated during launch. The tests confirm that the structure can withstand the stresses of liftoff and space travel, ensuring the rocket's overall safety and reliability. The rigorous testing regimen is a reflection of China's commitment to ensuring the highest standards of safety and reliability for its space missions. Each test provides valuable data that helps engineers refine and improve the rocket's design, addressing any potential issues before the actual mission. This meticulous approach is crucial for the success of the upcoming lunar missions, where any failure could have catastrophic consequences. China's blueprint for lunar exploration is as ambitious as it is meticulously planned. The Long March 10 rocket is central to this plan, designed to facilitate a series of complex maneuvers that will ultimately enable astronauts to land on the moon and conduct scientific research. The mission strategy involves launching 2 Long March 10 rockets, each with a specific role in the overall mission architecture. The first launch will carry the Mengzhou spacecraft, a crewed module designed for deep space travel and high-velocity atmospheric re-entry. This spacecraft will enter lunar orbit, awaiting the arrival of the second component of the mission, the Lennu moon lander. The second Long March 10 rocket will transport the Lennu lander, which is equipped with advanced landing and exploration technologies. Once both spacecraft are in lunar orbit, they will perform a critical rendezvous and docking maneuver. This process requires precise navigation and control, ensuring that the 2 modules can join seamlessly in space. The success of this maneuver is crucial, as it allows the astronauts to transfer from the Mengzhou spacecraft to the Lennu lander, preparing for their descent to the lunar surface. The descent phase is one of the most challenging aspects of the mission. The Lennu lander is equipped with a propulsion stage that will control the descent, ensuring a soft and controlled landing on the moon's surface. This stage uses advanced engines capable of variable thrust, allowing for fine adjustments during the landing process. The lander is also designed to handle the moon's harsh environment, with systems in place to manage temperature extremes and dust exposure. Once on the lunar surface, the astronauts will exit the lander and begin their scientific exploration. They will use a rover to traverse the lunar terrain, conducting experiments and collecting samples of lunar soil and rock. These activities are not only aimed at advancing our understanding of the moon, but also at testing the feasibility of future long-term lunar habitation. The samples collected will provide valuable insights into the moon's composition and history, potentially revealing new information about the early solar system. After completing their surface operations, the astronauts will return to the Lennu lander, which will then lift off from the moon and re-dock with the Mengzhou spacecraft in lunar orbit. This re-docking maneuver is as critical as the initial docking, ensuring that the crew can safely transfer back to the spacecraft for their journey home. As we conclude our journey into the remarkable strides of China's space program, it's clear that the Long March 10 rocket marks a new era of exploration and innovation. This advanced rocket not only represents a significant technological leap, but also symbolizes China's unwavering commitment to pushing the boundaries of human space travel. The successful tests of the YF-100K engines and the detailed mission blueprint underscore the meticulous planning and engineering prowess that have gone into this ambitious project. With the goal of landing astronauts on the moon by 2030, China is not just participating in the space race, but is setting new benchmarks for future missions. If you enjoyed this video, don't forget to like, share, and subscribe for more introducing new subject. See you next time.